Hello everyone, in this video we are going to talk about chiral carbons and non-chiral carbons in the stress hormone called cortisol or hydrocortisone. Let us first count the total number of carbon atoms. We have a 6-membered ring here, so 6 carbons, and then another 6-membered ring, but we have 2 contact points here, so therefore let's put it as 4. So together it's 10. Another 6-membered ring, 4. The reason I am putting 4 because we shouldn't double count. So that's why I am putting it as 4. Because it is fused together, 2 contact points are common. So when I count the first one, I am counting it as 6. But when I count the next one, I am counting it as 4 because these 2 points are common. So 6 plus 4 plus 4, and then here it is 3 because they are all fused together. So it is 17, and then we have a methyl group here, 18, and then we have another methyl group here, 19, 20, 21. So in total we have 21 carbon atoms. So in that some of them are chiral and some of them are non-chiral. So let's find out the non-chiral carbons and then we will verify the chiral carbons. So non-chiral carbons are those that would not be attached to 4 different groups. So chiral carbon is something that would have 4 different groups around it. So that's a chiral carbon. But when it comes to non-chiral, then methyl group will be non-chiral because we have 3 hydrogens. So if it is connected to one more unit here, together it would become 2 different groups, not 4 different groups. So methyl group, non-chiral. Methylene groups, that is also non-chiral. And then carbonyl carbon, that is also non-chiral because the hybridization here is sp2. And then carbon-carbon double bonds. Here also hybridization sp2 and they are non-chiral. Because for chiral carbon the hybridization will be sp3. Even though for methyl group it is sp3, but it is still 2 different groups, not 4 different groups. Here also the hybridization is sp3, but we cannot count this because together it would become 3 different groups, not 4 different groups. Let's count all these things. Then we can figure out the non-chiral carbons. Let's go with the methyl group first. We have 2 methyl groups. So 2 here. This one as well as this one. And then methylene groups. 1, 2, 3, 4, 5, 6, 7, 8. So 8. And then carbonyl carbons. 1, 2, and then carbon-carbon double bond. We have 1, but we should write it as 2 because it is 2 carbons. So together this is 8 plus 6, 14. Now mark the remaining and those will be chiral. We can verify that. So 1, 2, 3, 4, 5, 6, 7. These 7 are potentially chiral carbons. So if we add together, then that would become 21. Let's verify the chiral carbons. We have an alcohol functional group, and then carbonyl group, and then methylene group, and then quaternary carbon. Therefore, this is chiral. We indeed have 4 different groups around this carbon. How about this quaternary carbon? Methyl group, methylene, and then carbon connected to OH and then CH. So we do have 4 different groups around it. And then here we have hidden hydrogen and then CH2 on this side, CH on this side, and then quaternary carbon. So therefore this is also chiral. Here also we have a hidden hydrogen, CH on this side, CH2, and then CH on this side once again. This CH is different from this CH because for this CH it is fused between 2 6-membered rings. For this CH it is fused between 6-membered ring and 5-membered ring. So therefore there is asymmetry. Therefore this is chiral. How about here? We have a hidden hydrogen and then CHOH and then CH and then quaternary carbon. Therefore this is chiral. How about here? We have alcohol functional group. There is a hidden hydrogen and then methylene and then CH. Therefore this is also chiral. How about here? We have a methyl group and then CH2 and then sp2 carbon and then CH. Therefore this is also chiral. So we have 7 chiral carbon atoms, 14 non-chiral carbon atoms. Total 21 that we already got. So 7 and 14. This means option C is correct.